Hello everyone, this is going to be a new lesson for HSC, but this time this is going to be a different type of lesson. So usually our videos were normally like one project in a video, but this time I'm thinking of doing a long-term project, which consists of different materials than what are in our normal like boxes. So what I'll be making is a remote control robotic hand with Arduino. So what is this? So what is this remote controlled robotic hand? So what I'm going to be making is something that can emulate the movement of our hand, or my hand, wirelessly through a glove without sensors. So this glove is going to consist with an artificial hand with flex sensors. And this artificial hand is going to reproduce movements of the hand with a control glove wirelessly, so that the hand and the glove, which works both with Arduino. So these are the materials that are going to be needed. So first, it's going to be obviously our Arduino. And we're going to see some components that we've never seen before, but I'm going to buy them and implement them so I could build this project. So this is going to be the Arduino Uno, right? There's going to be an Arduino LilyPad mainboard. The third one is the XB-S1 trace antenna. And I'll show you what these functions do in a later video when I'm actually building. So this first one is going to be the SparkFun XB Shield. This one's going to be SparkFun XB Shield for LilyPad. And the third one is going to be the SparkFun LilyPad FTDI basic breakout, which is 5 volts. This first picture is going to be the flex sensor for the gloves, the 47 k ohm resistors, and some AAA batteries. And obviously a 3 times AAA battery holder, a 9 volt battery, which is rechargeable, and a robot shield, which is the third one, with a 5 volts servo meter. And so what we're going to do for the control glove, obviously we're going to buy, we're going to need an elastic glove, or I guess any type of glove. We're going to need a LilyPad Arduino board. There are normally different versions, which usually only have 4 analog inputs, but they work exactly like the classic Arduino Uno. So, but you still need to pay attention on the voltage. So we're going to use the XB module, a shield to connect the SB module, 5 flex sensors for each of our fingers, and the resistors, the battery pack, and as I said, the FTDI adapter. And for the robotic hand, we're going to get a steel structure, which we're probably going to buy instead of 3D printing. Some wood for the fingers, obviously our Arduino Uno board, 5 servo meters, which are each 5 volts, and a servo meter shield, and a shield to connect the XB module, wires, a 9 volt battery, and there's going to be a little more tools that are needed later, but we'll get onto them when we start building. So now I'm going to show you how my plan of how we're going to make the glove. So now I'll be talking about my thoughts, or about what I'm gonna do with this glove. So first, this is the schematic of what I'm gonna do, and so I'm first gonna choose the right position of the components, and then connect everything with the proper length of the wire. So, and something like this. And I'm going to make an analog read with the Arduino LilyPad so that I can have a voltage divider, because the flex sensors don't work as potentiometers. And with that, I'm going to solder the 5 resistors on the LilyPad board and to the 5 different analog pins, and then solder the flex sensors onto 5 different analog pins and to the other, so it could be positive. So I just searched this up on the internet, and I'm going to make it look something like this. So yeah, So I'm gonna connect the XP shield with the 2 wires and the battery pack connected with the glove. And so with these sensors, I'll be able to kind of move my hands to move this this kind of robotic hand. And so with making the robotic hand, I'm most likely going to use 3D printed parts, but because I currently don't have a 3D printer, I'm going to buy it online. And with the 3D printer, I'm going to circuit the robotic hand, but that is what I'm going to explain, or what I'm going to build on next lesson. So thank you guys, and see you guys next week.